In this video, we are going to talk about Cartesian tensor. Cartesian tensor. Now, consider the standard basic. This is a unit vector E1, unit vector E2, and unit vector E3. This is x1, axis, x2, and x3. Now, suppose you have the scalar, the dot product A dot B. Okay, because EI dot EJ is equal delta IJ. What means that? Now, delta IJ is equal to 1 if I is equal J, and 0 if I is different from J. You all right? We saw this before. So, here you have A1, B1 plus A2, B2 plus A3, B3. This is a scalar. There's a number, okay? So, we say that this is a tensor of order 0. Okay? Now, scalar is a tensor of order 0. Now, consider this vector here. Okay, here we can put this under a summation. Okay? Now, this is equal a sum. Let's put I is equal 1 to 3 AI BI. Okay? This will be A1 B1 plus A2 B2 plus A3 B3. Now, consider a vector. This vector also we can use the sum I or J is equal 1 to 3 VI EI. Okay, this is equal V1 E1 plus V2 E2 plus V3 E3. Okay, this you can put in the summation here. I is equal 1 is V1 E1 plus V2 E2 plus V3 E3. So this we say is a tensor of order 1. Okay? So a vector is a tensor order 1, and a scalar like temperature and mass, okay, they are scalar quantities. We say that they are a tensor of order 0. So this tensor of order 0. Okay? Now, suppose I want to write, I will erase here, okay? I will erase here to have a space, okay? Suppose I have a vector V, okay? V is equal V1 E1 plus V2 E2 plus V3 V3. Okay, you see, I can represent this vector V as E1 dot V, in this case, okay, VI plus E2 let's put, instead of I here, let's put E1. Okay. Okay. Now, E2 dot V E2 plus E3 dot V E3. Okay, it seems that this is a little bit confused, but it's not. Now you see that we can represent V like this. Now, let's substitute V over here. So I'll just work with this term here, okay? Then I'll write down V. Let's put E1 dot, now, V is V1 E1 plus V2 E2 plus V3 E3. So this is V, okay? Now, this is, I'll put here E1, okay? Only with this term here, okay? I'll put here equal. Now, let's see. E1 dot E1 is 1. So this is V1. So this is V1. Now, E1 dot E2 is 0. E1 dot E3 is 0. So here we have V1, but there is E1 here. So you put E1 here, okay? Plus, now I will work with the second term over here. I just put 2 and 2, okay? And I write down here. That's the same V, okay? Now, E2 dot E1 is 0. E2 dot E2 is 1. So here's the V2. Now, E2 dot E3 is 0. Then it will be E2, V2, E2. You see, because E2 dot E1 is 0, E2 dot E2 is 1. So this is V2. E2 dot E3 is 0, so it will be V2, E2, which is here. Plus, now, I put 3, the third term there, okay? This is 3. Now, E3 dot E1 is 0, E3 dot E2 is 0, E3 dot E3 is 1. So here I have V3, E3, V3, E3. Okay, why I'm doing this? Because we see here, okay, and a vector V and E1 over here. See, there is no sign in between here. There is no sign here. So this, and this, they are, look, they are a second order tensor. Okay? They are second order tensor, okay? So V can be represented, okay, in this form over here. So using a second order tensor. Okay? So we can write a Cartesian tensor using the standard basis. This quantity here is a scalar, okay, which is a zero order tensor, okay, and order 0, okay. This is a vector. You see, there is EI over here. You can put J to 1 to 3, AJ, EJ, so no problem. So this is a vector, okay, a tensor of order 1. This, I'll call this a tensor of order 2. See, EY, EJ, okay? Here, EI, EJ, EK. So, the tensor of order 3, okay? And so on, okay? Now, we see the order of a tensor looking at the unit vectors, okay? This is a tensor of order 3. You already know, used a component of a tensor order 2. I'm sure that. Okay, when you play with matrix, you used, I'm sure, Aij. Okay, you didn't use this this is called dyadic. Okay, this is called dyadic. Now, I'll give you an example. Okay. Suppose you have a matrix A. Let's put 1, 2, minus 1, and 1. This matrix, okay, operate in a vector, let's say vector 1, 2. Okay, this yields and another vector. So this is 2 by 2, this is 2 by 1, okay? Now, first row times this column. So you have 1 plus 4, this is 5. Now, minus 1 plus 2, minus 1 plus 2, this is equal 1. So, I'll write down this as a second order tensor. Okay, I write down like that. I'll put 1, E1, plus 2, E1, E2. Okay, first row, second column. Minus 1, E2, E1, plus 1, in this case, okay, this is 1, E2, E2, okay, dot, this vector here, 1, E1, plus 2, E2, okay. Now, let's see. This is a second order tensor. Second order tensor, you see, this is a second order tensor. This is a vector. This is a vector. This second order tensor dot this vector. Okay. Now, this term dot this term will be 1 E1. 1 E1. Plus this term here dot this term will be 0 because E1 dot E2 will be 0. Now let's see this term over here. Okay, this term dot this term, E2 dot E1 will be 0, so E2 dot E2 will be 1. So here will be 2 times 2 will be 4 E1. You see, look, I'll repeat. It's quite easy. You have to pay attention. Look, this term here, dot, I'll put a dot here, okay? This term here, dot this term, okay? E2 dot E1 will be 0. Now, E2 dot E2 will be 1. So, it was left E1, which is here. So, 2 times 2 is 4, okay? Plus, now, this term here dot this term, okay? So here you can see that E1 dot E1 will be 1, okay? Now it was left E2 over here. So this is minus 1, okay? See, E1 dot E1 will be 1, minus 1 E2. E2. Now, the last one, you see, this term dot this term. E2 dot E1 will be 0, but E2 dot E2 will be 1. So, 1 times 2 is 2, plus 2 E2. Now, this will be 5 E1 plus 1 E2. You see, the dot product of the second order tensor with this vector will be 5e1 plus 1e2. See, exactly this component over here. You see? So when you work with matrix, actually you are working with the component of a second order tensor. So this here is a second order tensor. This is a first order tensor. First order tensor. This whole thing here is a second order tensor. All your study about matrix, you see, you just did. Okay? Now, but you used not the second order tensor. You just use the component. This I can see component of a second order. See, component of a second order tensor here. Here we have the component of a first order tensor. Okay. Now you see, this is a vector too. These are components of a first order tensor, like this. Okay, the same here. Okay. There is a convention about this tensor over here. So what we do is this: forget the unit vectors ei, ej, ek. Just work with the component. Okay, so let's write down here the components of this vector. This is a vector. Why? Because there is only one specified unit vector. Here is 2, here is 3. So let's consider this vector. Okay, I just write ai. Okay, this is a vector. Okay, this index here. Okay, I write I is a free index. I'll explain to you what means that. Okay, now for I is equal 1, I have the component of vector A. There's a vector A. You see the vector A. Okay, you see, for I is equal 1, okay, I know that the component of this vector, okay, belongs to E1 axis, okay, the x1 axis. So I just write the scalar quantity ai here, okay. This is a one free index. Now, forget the summation and write down aij. Okay. Now, aij are the components of this second order tensor. Let's put here. This is a second order tensor. I forget the summation and also the unit vectors. Okay, the standard basis. Then I work with aij. So this is a second order tensor. Here, I, J are free indices. Okay? So, when I see two free indices, I say that these are the components of a second order tensor. Okay? In general, you say, oh, this is a second order tensor. Okay, you don't say these are the components of a second order tensor. You look this and see, oh, this is a vector because it has only one free index. So here you have, okay, extrapolating this idea, okay, A, I, J, K is a third order tensor. Okay, you have three free indices. Okay, if you have I, J, K, L, okay, you have a fourth order tensor and so on. Now, you see a scalar, you see, there is no free index. This is a scalar, okay? A scalar, there is no free index. So this is order 0, okay? This is order 2. When I say order, it's a tensor of order, okay? Tensor order 2. And this is order 3. Okay? Now, you can write down. Okay? So this is a convention. Okay? This is a convention. Now, going one step ahead, okay, we will see what is dummy indices. Dummy indices, this is Einstein notation. Okay? Now, suppose I have a tensor A, I, J, J. Okay? This Aij is a tensor. Aijj is not a tensor. You see, when you have Jj, this means that you have a summation of J is equal 1 to 3 Aijj. Okay? Now, this is the same as this, so you have AI 1 plus AI 2 plus AI 3. That's what you call, okay, this J as a dummy. Why? Why is a dummy? I is a free index. Okay? J is a dummy index. Okay? J is a dummy index, I is a free. Now, you see, here I have only one free index. So this quantity here is called a vector. Okay? Why is dummy? You see, look, I will raise here. Okay? I put K and K. So this will be K. Here K and K. K and K. See? And the same sum. That was dummy. I could put L or M, N, doesn't matter. So now you see, look, for you to characterize a tensor, we have to see in the components. We work only with the components. You see, forget this unit vector. This is only components. You see how many free index do we have in the expression? For instance, I'll give another example. See? No, look. I'll raise here, and I'll do like this. Suppose we have a tensor B, M, N, M, P, and Q. You see? Look. How many dummy index do we have here? Only one. You see, it's M. So this is free free and free. So you have 3 free indices. Okay? What are they? N, P, and Q. N is dummy index. N is dummy index. Okay? Now, we say here that this is a third order tensor. See, we are looking only the component. We are not looking here. So I'll present here some examples, okay? We'll discuss. Now, suppose you have a scalar product, A dot B. We saw this is a summation of AI, BI. I is equal 1 to 3, okay? Let's forget the summation, and here we have AI, BI, or AK, BK, okay? When you see here I, okay, I is dummy. K is dummy. No free index here, so we have only dummy. So this is a tensor of order 0. Okay? A scalar. This is a scalar. Now, when you see this now, from now on, now suppose you have, for instance, AI, BI, J. Okay, here. You see, look at the free index. There is only one free index, so for sure this is a vector. Okay, convention. Okay, this is a vector. I is dummy. So if I put here, instead of I put K and K, okay, this is dummy. So this is a free index, vector, okay? One free index. Okay? Now suppose we have, let's write down here, okay? For instance, P, M, N, L, Q, M, N, K. Okay? Now, how many free index do I have here? Okay? Oh, look, these are dummy. Okay? These are dummy. So this is a second order. Okay? Tensor.